So the first one is to talk about this. Now here we have sine x over cos x. One, we know that cot x equals to 1 over tan x. So here, from using the SOHCAHTOA, sine x is opposite over hypotenuse divided by cos x, which is adjacent over what? Hypotenuse, right?
Mm-hmm.
Mathematically, this can cancel out this. Do you agree?
Yeah.
Do you agree? Yeah. So here we have opposite over adjacent. And cot x is 1 over tan x. And we know that tan x, or tan theta, tan x is opposite over adjacent. Right?
Mm-hmm.
Even looking at this, it should be the opposite. Sin x over cos x can never be cot x. Even the expression is wrong itself.
Really?
Yes, it should be tan x. Sin x over cos x should be tan x. It is cos x over sin x should be cot x. Okay? Should be the inverse, because if you solve this, you have opposite over adjacent, which is the same thing with tan x. Okay, the reciprocal is going to be the cot x. So that's one thing about this. And we have so many ratios like this, but in which I don't think you're going to need. We have a lot. We have sine square x plus cos square x equals to 1. You have cosec square x, we have secant square x. That is, if you delve into that, we are moving into advanced trigonometry, which you might not need. Okay? So that's it. So now let's go back to what we have for today, which is variations. You should have taken the pictures, I forgot. But if you want, you can always check or we watch. Now, bismillah. Here we have variations. From the word variation, variables, something is changing, not fixed. Okay? It's changing. Don't get distracted with this. Now, number one, under variation, we're going to talk about direct variations. Number two, we talk about inverse. Number three, we talk about joints. So those are the three types of variations we can talk about. Now, when we talk about the word direct variation, under the direct variation, here we have that A is directly proportional to B. What does this mean in real life? Do you have any idea?
For example, like planting a tree, the longer it grows, the higher, the more like it grows, the longer it will be, larger it will be.
Okay, another example?
The more you work, the more money you get.
You know, there's this adage in my country, we say, "Iṣẹ́ kọ́ lówó." It is not it's not by hard work. No, that's wrong. It's not how much you work that determines how rich you're gonna be. Alubarika loju. It is the blessing of God that makes you rich. Sometimes, because if it is how much you work, look at some people doing bricklaying. or even here in America, bricklaying is very, is very, how do I put it, luxurious, because you're going to get a lot of money. But look at somebody that just sweeps the floor or just doing menial jobs and you work almost throughout all day. Compared with somebody that is a data scientist or data engineer and you work for a few hours and you get a lot of money. Yeah, your example is perfect. Yeah. I mean, the longer you work, the more money you get. A is directly proportional to B. What this says is that if A increases, B also do what? Increases. What happens to A must happen to B. Simultaneously, if A decrease, B also do what? Decrease. Like a real life example. For example, you have somebody have a father who is earning like $100,000 every month. You know, even you yourself, or maybe earning like $1 million every month, you're gonna have your own private jet. Your standard of living is gonna be very high. Compared with somebody whose father just earned maybe less than $500 a month. So your standard of living is going to be different. So what happens to A must happen to B. What happens to A, if A decrease, also B must also decrease. This is called direct proportional. Direct effects, the same effects. So that is direct proportionality. Now, if you want to write this mathematically, here you're saying A is directly proportional to what? B. This is the sign. This is direct proportionality sign. I mean, this is proportional sign. Now, here, how can you equate this? Any idea? You've done this before?
Okay, we could have like a slope, intercept form, a slope form.
Yeah. So your A is going to be equals to KB. For this proportionality, K is what? Is called proportionality constant. Proportionality constant. It's called the proportionality constant. So your K shows that what happens to A is simultaneously happens to B. So your K can show the constant growth that happens. So with this K, you can see that, oh, if, for example, when I work for 2 hours, I earn $10. What if I work for 5 hours? How much am I going to earn? So this K can tell you how much you're going to earn. So it shows the constant growth that is happening. So this is the purpose of this K. And then we're going to solve some examples on this just to show. So if you have examples, you can read it out on direct proportional. Any example? Show me. Just read it out. Okay.
If the number of calories C varied very directly with the amount of time T is spent exercise, almond burned 312 calories in 65 minutes of exercise.
If the number of calories C is what?
Burned very directly with the amount of time.
Varies directly to time.
In spent
C.
exercise.
Okay? Now I'm just going to shorten it. If the number of calories C varies directly to time C. Okay?
He burned 312 calories in 65 minutes.
He burns 300 and what? 12 calories. In how many minutes?
65.
In 65 minutes. So the time is a minute, right?
Yeah.
Okay. Proceed.
How many calories will he burn in 90 minutes?
Okay, how many calories will be burned in 90 minutes? Now, this is how direct proportionality works. So you're going to be giving the first, you're going to be giving the quantity for A, you're going to be giving quantity for B. And the second question is now, the main question is now going to be, what is the other quantity given this quantity? So the first thing you have to do is get the constant. Sometimes when you are given this information, you just be asked, what is the proportionality constant? In fact, you might not be asked to get this. The question is just going to be, what is the proportionality constant? Now, to do this, we have two quantities, C and T. So the question says, if C varies directly to what? T. So this is the first sentence. Okay? C varies directly to T. Now, you have to rewrite this as saying C equals to what? KT. I love to use K as my constant. Now, the question says, it bonds 312. That is, if C is 312, T is what? 65. It is K times 65. So let's get K. So how do we get K?
Inverse.
Yeah, divide both sides by 65. Divide both sides by 65. So my K is going to be what? 312 over 65. I think I have a calculator in there. You can pick my calculator too. This is going to be like a decimal. Let me check.
4.8.
4.what?
4.8.
4.8, okay. So here we have 4.8. So this is the constant. Now, the next question is, the main question now is, what is the number of calories if T is 90? So you have to go back to this. C equals to KT. Now, what is going to be the value of C when T is what? 90. So the next thing you have to do is plug in this constant, which is 4.8. Multiply by T, which is what?
90.
90. So what is going to be the answer?
432.
432 calories. What can you say about this?
That you lose 432 calories if you exercise for 90 minutes.
That means the more time you spend exercising, the more calories you burn. You see, when you spend 65 minutes, you have 312. When you increase the number of time, you burn 432. You understand?
Yes.
Now let's do. I'm going to give you a question to do right now. Yeah, read another question.
The weight of a liquid varies directly to its as its volume.
Example 2. The weight of a liquid
Varies directly to its volume.
varies directly to its volume.
A liquid that weighs 24 pounds.
A liquid that weighs how many pounds?
24.
24 pounds.
Has a volume of 4 gallons.
Has a volume of 4 gallons. Okay?
If a liquid has volume of 13 gallons, what is its weight?
Has a volume of 20 gallons, right?
13.
30 gallons. What is its weight? Try this in a few minutes and let's see. Can I just put something down? You can get some papers there. Try it.
I think the answer is 2.166666 repeating.
2.1? 0.1? You don't have
I mean
a calculator.
5.
But you don't have a calculator with you. Then how can you get the decimal? Is the answer over there?
I mean 5. It should be 5. No, it's not right there. It should be 5, I think. For 30 gallons, it should be 5. Because 4 divided by 24, 24 divided by 4, that's 6.
Let me
6,
confirm.
30 divided by 6 equals 5.
Let me confirm his answer soon. Maybe you get the same too. So if your own answer is what? Say it again.
5.
5. Okay. 5. Okay, let's see. I'm not sure. You know it should be wrong because look at it. Your gallons is increasing. How will the pounds decrease?
Yeah, it's 180.
180.
No. I did 30 pounds, not
Don't
gallons.
use shortcuts.
I did 30 pounds instead of gallons. 30 pounds is 4 gallons.
Even if it is 5 gallons, the pounds should increase.
The pounds would be 30. That's why I flipped it. I flipped the numbers.
Okay, let me just do this. Okay. The weight is directly proportional to the what? To the volume. That is W equals to kg, right?
Yes.
So if the weight is 24, our volume, so dividing both sides by 4, by 4.
The 30 pounds.
So K is 6, right?
Yeah. Times 30.
So using the same thing here. So now we want to check the weight. If the volume is 6 times 30, 180 pounds. Don't use shortcuts.
I divided 30 by 6.
Yeah,
I thought like
I
30
know.
pounds.
I
So
know. And it's because you are not using your pen. That's why you made the mistake. If you write it down, you surely get it. Yeah. Questions. You know, there's this competition we call Olympiad competition. Maybe I will show you a page. They have series of math. Actually, it used to be just mathematics competition. Now it is a combination of math and science. So they expect you to answer as many questions as possible in 1 minute. Some students answer like 15 questions in a minute. That's crazy. You watch it, you be like, even me myself, I used to train my students for the competition, but it's scary. It's not easy. No, we are done with direct derivation, right?
Yeah.
So if you see any problem that pop up on direct derivation, you can do it. You should move forward.
Yeah.
One more question. Should we do one more?
I think we can just go for. Go next.
Go to next. Good. So we are done with direct. Let's move to inverse. Now, let's say A varies inversely as B. The word inverse, what do you understand with inverse?
So if A increases, B decreases?
Good. So that means if A increases, B decreases. And also, if A decreases, B is going to what? Increase. The reverse is the case. Can you give me a real life example? In
I
this case?
think water flowing out of the tank. The more time, the less water there is. If you go before the water decreases, there's gonna be more water.
I don't understand.
So
You have
the
a
tank-
gallon of water?
Yeah,
Okay.
and there's a hole,
Okay.
so it's going out.
Okay.
The more time, the less water there is.
Oh. Yeah. Makes sense. What about you?
And back to the water thing. If you have a water bottle and a cup, if you put the water in the cup will increase and the bottle will decrease.
Okay, I think you love water. You love to drink water.
Drink your water.
Yeah. Let me think about an example. You see this life? Yeah. Actually, people don't like this example, but it's a reality. People celebrate their birthdays. The more you live and you're happy, oh, I'm 20 years old, oh, I'm 30 years old, the closer you are to the exit. That's another example. Now, for inverse variation, here we have A varies. Anytime you are using inverse, it should be 1 over B. This is inverse. It's going to be like in reciprocal form. So here we have A equals to K over B. That is inverse. Inverse. Just it. Instead of having KB, you have K over B. Okay. Let's look at, let me just write it in. So we can have space. You know, there's one mistake people often make in mathematics. And I think some teachers also make the same mistake. The use of equals to. Yeah, for example, I'm giving you this, I ask you to solve this quadratic equation. I'm just giving an example. Plus 3x plus 6. And then they will say, okay, x squared plus this plus this plus this equals to this. No, you can't just bring equals to. It's never possible. It's not an equation. Instead, you should write implies. Okay, there was a time I made a video on YouTube and I made the same mistake. I forgot. Immediately somebody just called my attention. You did this, and unfortunately the videos have gotten some views and people don't even observe that mistake. But a mathematician just saw it and called my attention to it. I have to go and delete it and shoot another one again. So it's very important. Now, this is what we have. Let's look at an example. Okay, check example 3. Inverse.
To balance a seesaw, the distance from
the distance, let me start from there.
The distance from the fulcrum that the person must sit is inversely proportional.
Let me short it. It's inversely
proportional to its weight.
Proportional to its weight, right?
Yeah. If a 72-pound boy is sitting 3 feet from it,
is 72. If a 72-pound boy is what?
Sitting 3 feet from the falcon.
3 feet from the fulcrum.
How far from the fulcrum must a 54-pound boy sit to balance the seesaw?
How far from the fulcrum must a what?
A 54-pound boy sit to balance.
54-pound boy sits from the fulcrum. You are a science student, right? Are you in science or arts?
What?
Here, you differentiate if you want to go to science, if you want to go to arts or commercial.
Yeah, engineering takes a lot of science.
Even in high school,
Yeah.
do you choose the kind of...
No, they, so you have to take a certain amount of class and a certain amount of science.
Okay.
So a certain amount of math, 4 class science and 4 class math you don't choose.
Okay, so you're doing physics, right?
We did physics once, yeah.
So what topic is this on physics? Fulcrum.
Yeah, this
Seesaw.
is seesaw, yeah.
What topic is that? Equilibrium. You've done equilibrium? Yeah.
I didn't go too much
You're
into physics.
gonna do practical of equilibrium.
Yeah.
If you're going to engineering, then you have something like this. You have to check the weight, the acceleration due to gravity, and some other things like that. It's very interesting.
Yeah.
So here we have the fulcrum. You can see this is inverse. If this is going down, this is going up. You know, seesaw, right?
Yeah.
If this goes down, this goes up, and if this goes down, this goes up. So this is like inverse variation. Now, here we're talking about the distance and we're talking about the weight, right? Okay, distance is the feet, weight is the pounds. Now, to do this, we have the distance, let me call it D. It's inversely proportional to the what? To the weight. Now, this is the same thing as saying D equals to what? K over W. We're done with the first sentence. This is done. Now let's proceed. If 72 pounds, that is the what?
That's the D. I mean W.
If the weight is 72,
Mhm.
the distance is what?
3.
3 feet. So you stop. Let's do this too. Step by step. What do?
Multiply 72 from both sides.
Yeah, well, sometimes we call it cross multiply.
Mhm.
This multiplies this. So your K is going to be 3 times 72. And that should be what?
216.
2,
216.
216. Now the next question is, how far? What is going to be the distance? We don't know.
Mhm.
So we have K to be 216. If the weight is what? 54. So what is going to be the distance?
4.
4?
Yeah.
4 feet. So what can you say about this? When the weight decreases, the distance do what? Increases. Do you see that? That's the application. That's the application. Now I want you to read one more question. And you're going to do that, and then we move to the joint, and that's going to be the end. You're not even taking the pictures.
Mhm.
Okay, this is what I'm going to do. After this, you can watch the videos, and I want you to write the note out against tomorrow, okay?
Mm.
So you write the notes and the solutions out against. So you show me tomorrow. Because that's the best way you can remember what you've done. When you write it out, document, it's going to be important. Now, let's read another example.
The amount of illumination I is inversely proportional
The amount of what?
illumination.
The amount of illumination.
Yeah, that's light.
Illuminate. Or illuminate. Illuminate, right? Light.
Yeah.
Illumination. Ha.
Is proportional to the square of the distance.
Is it proportional? That's going to be direct proportion.
It's inversely proportional.
It's inversely. If you just say proportional. Yeah, I love this one. Square. Yeah, sometimes we have square root, sometimes we have square. Proportional to the square.
Of the distance d.
Of the distance?
D.
D. Okay, good.
If 70-foot candles of illuminating light
It's 74 candles of light.
is measured 2 feet away from the lamp.
It's measured 2 feet away from the light. Right?
Yeah. What level of illumination might we expect 1/2 foot away from the lamp?
What level of illumination What level of illumination?
Yeah. Might we expect for 1/2 foot away from the lamp?
Will be expected, right? Or might be expected.
We might expect.
Okay, we might expect.
1/2 feet away from the lamp.
In
1/2 feet
1/2 feet
away from the lamp.
away from the lights. Oh. Do this. Write something out. I want to see what you want to do. Don't just think. Let me give you a pencil. Don't worry. You can have it yourself. Take. Use it. No. Let him use it. Use my book. Right? you can just do it at the top here. Yeah, take your pencil. I'll show you what you've done. So, possibly we can do this joint variation tomorrow. This time it's not available. What is the time now? This is 6:09. I'll be playing soccer. Do you play soccer? Why? You don't have time. So what's the answer?
98.6 repeating.
98.6. You got 98.6.
I
What
know.
about you?
Cancel.
You need a calculator?
No, I got it.
I just want to be sure of your answers before I do it.
The square root of 70 divided by 4.
That's why you need a calculator.
Yeah, exactly.
Take. Don't just think about it.
2.0915.
2.09, right?
Yeah.
That's the answer. Okay, let's see who's right and who's wrong. Okay, it says the amount of illumination high we have I is inversely proportional to what? To the square of the distance D.
Yeah, I got it.
You see a mistake. So here we have I to be equals to K over D squared. Sometimes we use square root, we use cube roots. I mean, different, not just a direct problem. Now, if 74 can do this, that is, if I is 74, and then we have the distance to be 2 feet, so we have K over 2 squared. So that is, we have 74 equals K over 4. So here we have K to be 74 times 4. And my K is going to be what? What's 74 times 4?
296.
Sure. Yeah, should be. Because 70 times 4 is 280. 4 times 4 is 16. 296. Now, the next question says that what is going to be the value of I? We don't know. And we've gotten our K to be 296 divided by 1.5 feet. 1.5 feet squared.
No, just 1/2, not 1.5.
Just 1/2.
Yeah.
Oh, I thought you said
Oh,
1.5.
okay. No, you got me wrong.
Okay, don't worry. Let's use
No, that's fine.
1.5.
Okay.
Yeah. Makes it interesting. So here we have 296. 1/2 is going to be what? 3 over 2 squared.
2.25.
And 3 over 2 squared is what? 9 over 4. Right?
Mm.
Because this is 3 over 2 all squared. 1/2.
1/2.
Yeah. If you square it, you have 9 over 4.
Yeah, 1.5, right?
Yeah, 1.5 squared. It's still the same thing.
It's just, that's the thing.
Okay.
2.25 and 9 over 4.
This is equivalent to 2 point what?
Same thing.
2.25, right?
Yeah.
It's the same.
Okay, yeah.
So 296 divided by 2.25. What's that?
100. Okay, 131 and 5 repeating.
131.6 candles lights. So none of you got it right. Yeah. So that is the answer to this. So we stop here for today.
Okay.
So tomorrow, inshallah, we do joint variation. But do two questions. I want to see the answers. Write it out. Write the question out. Write the answers out. On 2 on direct variation, 2 on inverse variation. And tomorrow we do what's it called? Joint variation. Inshallah. So we stop here. So